Good morning, everybody. Happy Friday. Got a warm up for you. Got some one volume and surface area problem, along with our regular diamonds and a 3x3 kin. I'll put a 4x4 on the back that I'll put the answers in the stream if you want to challenge yourself. But all you have is a couple of integers, 4 integer problems, adding and subtracting, and 2 area and perimeter problems. The challenge here is this is we call it complex or compound shape. You need to figure out the length of this line and the length of that line before you can get the area and the perimeter. And don't forget, on the triangle, you're doing 1/2 times the base times the height. Okay. And I'm going to zoom in so you can see the top half, copy, and then zoom in for the bottom half. Okay. Okay, I lied. I'm going to zoom out. There we go. Zoom in, and this I'll put it up here so I think you can get both. Not quite. Okay, so get those diamonds, get that kin, and then we'll press pause. Okay, now you get the area and perimeter of the complex shape and the triangle, and then you get the volume of that. Remember what that's called? It's called a rectangular prism. A prism is kind of when you take a two-dimensional shape, like a triangle, a rectangle, or a square, and then you duplicate it. So the top, one will be the top, one will be the bottom, and then you have straight sides that go straight up, and that's talking 90-degree angles. Okay, so the top is the same as the bottom. That ends up being a prism. So if I have a rectangle on top, that's 12 times 10. The bottom is going to be 12 by 10. And then you have straight sides, so that makes it a rectangular prism. If I had a triangle on top, okay, and I duplicated that and had the same shape on the bottom, and then I had straight sides go straight up and down there, that would be a triangular prism. You can, if you want, have a hexagon on top and a hexagon on the bottom, and that would be called a hexagonal prism. Okay. And what's kind of cool about knowing that is when you get the volume of a prism, you pretty much get the area of the top or bottom. You know, in geometry, they'll say the base. The base is the same as the top. And they'll do a base with a capital B instead of a lowercase b, like when you get the area of a triangle. And capital B means it's the area of the base times the height. And it's the same. You get the area of this rectangle times how tall, that's the volume. Get the area of that triangle times how tall, that's the volume of that triangular prism. Get the area of that hexagon times the height, and that's the volume of the hexagonal prism. And it even works when you get to what's called a cylinder. A cylinder is like a circular prism, right? If you can get the area of that circle times how tall it is, that's the volume of that cylinder. It's kind of cool to know how it all works out. All right, so copy that down and get started, and we'll go over this in a little bit. All right, let's get some answers here. Okay, first off, the diamond that has a product of 22 and a sum of 11. Remember, the product means you're multiplying, sum means you're adding. What two numbers work there? Hopefully you figured out that's a 4 and a 7. Okay, how about 48 and 19? A lot of people want to go straight to 6 times 8 because you know those facts, right? 6 times 8 is 48. But 6 plus 8 is not 19, huh? So what else might work? Well, I think you've heard me tell you before that when you have products, you can take the factors, and if you double one number, like I double the 6 again, and take half of the other, take half of 8 is, you will get the same product. And that works both ways. If I take half of 6 and I double the 8, I will get the same product. And 3 plus 16 ends up working there, right? And again, that'll work forever. What's half of 3? 1 and 1/2, right? If I do 1 1/2 and then double 16, get 32. 1 1/2 times 32 will also be 48. How about half of 1 1/2? What's half of $1.50? 3/4 of a dollar, huh? Double 32. 3/4 times 64 will also be 48. That'll go forever. It's kind of cool. It doesn't just work with 6 and 8. It works with all products. And it doesn't just work when I take half and double. I could take a third and triple. Right? What's a third of 6? What's 8 tripled times 3? What do you think 2 times 24 is going to be? And then again, that was forever. Kind of cool. Anyway, let's go to that kin. I would start with this square here. Now think to yourself, why am I starting with this square? Well, this doesn't tell me much. But this, I know one of these has to be a 1 and the other has to be a 3. I cannot have a 2 in either of these boxes, but I need a 2 in this column. That's why we're starting there. That has to be a 2. That means these two have to add to equal what? Well, if these 3 add to equal 5, and I already used a 2, these have to add to equal 3. How can you make 3 when you add 3 and 0, but I can't have a 0? 2 and 1's it, huh? Can I have a 2 there? Nope. So where's the 2 go? Where's the 1 go? And the dominoes start falling. If I have a 1 there and a 2 there, what should go there? If I have a 2 in this row, a 2 in this row, no 2 in this row, but I have a 2 in this column, no 2 in this column. And again, we figured out that has to be a 3. I have a 2 and a 1 in the top row. What goes in that top right? Hopefully figured out 3. 3 times what is 3? Or I have a 3, I have a 2, I don't have a. And 3 times 1. I have a 2, I have a 3, I don't have a what? A 1. And I have a 1 and a 2, but not a. Let's just double check. 2 plus 1 plus 2, is that 5? Yeah. 3 times 1, is that 3? Yep. 3 minus 2, is that 1? Yes, and 3 times 1. All right. On to the integers. If I owe $18, that's a negative 18, plus I owe 6, I owe a bunch, huh? I owe more now. I owe 24. How about if I owe 18 plus I have 6? This time I'm going to pay that 6 I have, and I'm not going to owe as much. It's not enough to pay it off. Still going to owe, but now I only owe 12. How about if I have 20 and I subtract a negative 5? That is confusing. I know 20 minus 5 is 15, but 20 minus negative 5? Remember what that is, okay? Subtracting is the difference, okay? So if I have 0 here, and I have 20, and I have negative 5, what is the difference between 20 and negative 5? Well, it's 20 right here and another 5. So the difference is negative. I'm sorry, not negative. The difference is 25. Now, what's an easy way to make sure we don't make mistakes on that? You've heard me say before, a lot of my former students say, hey, you taught me a few different ways of doing this. But whenever I saw a subtraction problem, I added the opposite, and that was very helpful. So instead of doing 20 minus negative 5, I'm doing 20 plus positive 5. Okay? And that is 25. All right. Now I owe 20, and then I just spent 5 more. That's confusing. Instead of subtracting, let's add the opposite. So instead of subtracting a 5, I'm going to add negative 5. And now it's easier for me to figure it out. I owe 20 plus I owe 5 more. I owe 25. Okay? All right. If this is 14 and this is 5, what should this be? Because really, this is going to be 5 right here. Right? This will be 5. So that part of the 14 is 5. What's left? 14 minus 5, 9. And if this is 7 and this entire height is 12, what's left? 12 minus 7, 5. Now, there are a number of ways of getting the area. I started to draw a line there. You can say 5 times 14 is 70. And this isn't 12 anymore. This is 7 times 5, 35. 35 plus 70 is 105. And that's square meters is the area. Now, that's one way of doing it. I could also have drawn the line here and said 5 times 12 is 60, right? And then 5 times 9 is 45, and 60 and 45 is also 105. I could also have made my rectangle complete and said 14 times 12 is 168, and then subtracted this right here. 9 times 7, 63, and the difference in 168 and 63 is 105. So all sorts of different ways of doing that, but whichever way is the easiest for you, okay? But if you do it two ways, that's a pretty good double check, huh? Like if it's on a test or something. All right, the perimeter is the distance all the way around. I need that 5, 14, 12, 5, 7, and 9. So 5, let's just start here. 5 plus 12 is 17, plus 14 is 31, 31 and 5 is 36, 36 and 9 is 45, and 45 and 7 is 52. Now, I want to double check. Start somewhere else. 14 plus 12 is 26, plus 5 is 31, 31 and 7 is 38, 38 and 9 is 47, 47 and 5 is 52, and that's meters. Show you a secret real quick. If that's a 7, that's a 7. If that's a 9, that's a 9. 9 plus 5 is 14. 7 plus 5 is 12. 14 plus 12 plus 14 plus 12 is 52. Kind of cool little trick you can do when they just cut out a corner of a rectangle, right? All right, on to the perimeter of this. I have 11 and 2/5, 14 and 2/3. Yuck. Different denominators. Thank you for the 18. It has no denominators, right? So thirds and fifths, I'm going to 15ths on that, right? And I did 3 times 5, so I go to 2 times 5. 2/3 is the same as 10/15. Here I did 2 times 5, or 5 times 3 is 15. So I go 2 times 3 is 6. And now I have 10/15 plus 6/15 is 16/15. And 11 and 14 is 25, plus 18 is 43. Now 16/15 is bigger than 1, huh? So I'm going to use 15 of those 15ths to make that 44. And if I use 15, I only got 1 left. 44 and 1/15 inches is the perimeter. Now the area, remember what we have to do there? 1/2 of the base times the height. Now I told you yesterday, if one of these numbers is even, just take half of it and multiply by the other. What's half of 18? 9. What's 9 times 10.2? Well, it's a little more than 90, right? 9 times 10 is 90. 9 times 2/10 is 1 8/10. So 91 8/10 square inches is my area. Okay. Now you can go over here and double check and pretend that's 102 times 9. And then figure out where I'm going to put the decimal. I'm going to go over one spot, and I get 91.8, just like I did there. Okay. All right, last couple here. The volume and surface area. And remember, the volume is the easier of the two here. Okay, even though it's cubic units, and kids like freak out. Oh no, it's cubic units. I'm scared. Don't be scared. All right. Volume, again, if it has straight sides, if it's a prism, get the area. They say the area of the base, but it's the same as the top. I always say the area of the top times how tall it is. Okay, and we're going to say V for volume. So what's 10 times 12? 120. So the area of the base or top, it's the same, is 120 square feet. Multiply that times 4. What's 4 times 12? 48. So 4 times 120 is 420. 4 times 120, 480 square feet. That's the volume. Okay, now that's the easiest one. The surface area is a little harder because there's more steps. Okay, each step by itself isn't that hard. Okay, what's the area of the top? You got it. What's the area of the bottom? The same. So on the surface area, you're getting the top plus the bottom, and each of those is 120. Then you're getting the front plus the back. That'll be the same. And what's the front? Well, I know that that's 12, so this is 12, and this is 12. When you find when you have a drawing of a rectangular prism, you have 3 sets of parallel lines. These 3 are horizontal, right? Remember, the sun comes up over the horizon. That's a horizontal line. Okay, these 3 are vertical, straight up and down, and these 3 are sort of diagonal. Okay, now when you have those 3 sets of parallel lines, those are all the same length. So this is 12, it's horizontal. This is 12, this is 12. The vertical, 4, 4, and 4. Okay, that's good to know because you got to go figure out the area of that front face. That's 4 times 12, 48. Well, the back will be the same. And then you have to get the area of that right face. And the left will be the same. 4 times what? Well, this is 10, this is 10, this is 10. That's easy, 40. Then just add them all up. Okay, it's a lot of steps, but none of those steps is that difficult. Remember, you can carry a ton of bricks from the front yard to the backyard. You just can't do it in one step. Okay? All right, add them all up. I have 8 plus 8 is 16. 1 plus 2 plus 2 is 5, plus 4 plus 4 plus 4 plus 4, that's 16. 5 and 16 is 21. And 2 and 1 and 1 is 4, 416. Now, I could double check, and I like to. I'm going to do the top, the front, and the right, and then double it. 208, when I double 208, I get 416. So the surface area, and remember, that's the area of each face. That's a front face, top face, right face, back face, left face, bottom face, right? Surface area equals 416, and that's square units. Remember, that's how many stickers it takes to cover it. Okay? All right, you did a surface area problem, you did a volume problem, and you guys are ready for the weekend. You earned it, huh? All right, have a good one, everybody.